So once again, welcome to a new problem. This time we have Diva, and she is being supported by a diving board. So there's a diver right here, and this is a diving board providing support to this diver. Um, and we do have a distance of 1 meter between the supports, and also the distance between the second support and the diver happens to be 3 meters. So happens to be 3 meters. Um, so we need to give some depth to the board itself to make sure it supports the diver adequately. And the two supports, the first one on the left is the A board, and then the second one is the B support. This is the information that's given. Another piece of information that we're being given is the fact that when the diver bounces off on the on the board, the torque to the diver is 1,800 Newton meter. And so, given that information, we want to find the mass M of the diver. That's what we want to find out. The diver is being supported by two reactions, A and B. So the first thing we want to write out is the fact that the torque itself is equivalent to the perpendicular distance from the diver and the force that the diver is applying. When the diver bounces that way, the force they're applying is equivalent to their weight, and then this would be their perpendicular distance, r perpendicular. Just to expand the problem, if the diver will say jumping at an angle, say like that, the board was at an angle, then the distance, the perpendicular distance, r perpendicular, would change, and the character would be r sine of theta. So this r perpendicular would be r sine of theta, given that this angle is theta. And that's just a general statement about what's going on with this type of problem. And so torque becomes, in this particular case, the total distance from this edge A up until that edge A, because we're computing the torque around A. So it becomes the total distance, which is 4 meters. So r perpendicular is 4 meters, and then we have to multiply that by the force itself, which is the mass times the acceleration. So our goal is to compute the mass of the diver M, and that becomes M equals to the torque of 4 meters times G, and the torque were given as 1800. So 1800 Newton meters, all over 4 meters times 9.8 meters per second squared. And so the meters cancel out, and then we simplify the problem, and so we end up, this is 9.881, that's more of approximation, so we end up finding that the mass of the diver happens to be 45.87 kilograms. So we're using torque in this problem to compute the mass of the diver. Remember, in this case, the diver is jumping that way, so the torque around A is given by the force itself, this force right here, times the perpendicular distance from A, which is that whole distance, and rearranging the problem, we're able to isolate the mass itself, which is torque over 4 meters times the acceleration due to gravity, and it gives us 45.87 kilograms. Hope you enjoyed the problem. Feel free to send any questions or comments, and have a wonderful day. Okay, thanks. Bye.